Hey everyone, welcome to hok'stutoring. I hope you're having a great day. Today I will be discussing the concept of concavity. So this will be present in chapter 6, so your differentiation chapter, and it is crucial that you understand the term concavity and how to apply it into different questions, okay? So let's get into the topic. Right, so the term concavity in the dictionary refers to the directionality of a curve, or in mathematical terms, concavity is the change in gradient along the curve or along the graph, okay? So in spec, there are two types of concavity. There are concave up and there is concave down, okay? Right, so I'll explain to you what these are. Concave up is when the gradient of a graph moving from left to right increases along the curve. So basically, an example is this part right here. The gradient, so on this example, the gradient on the left hand side or the leftmost part of the graph would be positive, but small positive, not that steep. But as it moves along the graph, it becomes very steep, a lot steeper, right? So the gradient is actually increasing. It becomes a big positive. Now, for concave down, an example would be this curve right here. So the gradient of the graph starts very steep on the left side, and then as it moves along the graph, it starts to decrease. It's still positive, but it is decreasing. See, the steepness of the curve starts to decrease, right? And that is called concave down. I'll provide you with another example right here, and these two examples were all positive gradients. Now I'll give you a negative gradient. So let's look at this graph right here, or this curve. So on the leftmost part of the graph, the gradient is steep, but it is steep negative. So a very big negative. A big negative means a very small number essentially. And then as it moves along the curve, the negative starts to decrease, right? The curve becomes less steep. But if it's less negative, the gradient is actually increasing, right? Does that make sense? So if I went from negative 100 to negative 10, for example, the number is decreasing, the negative is decreasing, so that means the gradient is actually increasing because negative 10 is bigger than negative 100. And over here, same thing for concave down, the gradient should be decreasing, and a great example is this curve right here, right there, okay? So on the left hand side of the graph, the gradient is negative, but it's not that steep, okay? So maybe negative 10, for example. But then as it keeps going along the curve, the gradient becomes very negative, essentially decreasing. So maybe negative 10 went up to negative 100, okay? So this is concave down and that is concave up. So pretty much the four type of curves that you can get. Right, but in chapter 6, you will also learn something about the point of inflection and the stationary point of inflection, okay? So let's have a look at the curve below. This is also in your textbook, but I want to show you guys what it means because the textbook just gives you the curve, doesn't really explain too much. We'll go into it in detail so that you can understand this term of concavity fully, okay? Right, let's look at the first cell. dy dx is bigger than 0, d square y over dx square is bigger than 0. Now what does that mean? So let's get all the possible curves you can get with the positive gradient first, because dy dx bigger than 0, that is gradient is positive. So the two types of curves you can get is this one right here. This is positive because that's a positive gradient, and you can also get this curve right here because that's also a positive gradient. Left to right, the graph is going up, okay? Now let's look at the d square y dx square. Now this is the second derivative. The second derivative means the rate of change of the gradient, okay? So let's have a look. On the leftmost part of the graph, this is very steep, so a big positive. This is a small positive. Now on the right hand side of the graph, this becomes less steep. So let's look at the first graph. Very steep, less steep. So the rate of change of the gradient is actually decreasing. The gradient is becoming smaller and smaller. But in this part right here, the gradient is becoming bigger and bigger. And because d square y dx square is bigger than 0, that means we want the gradient to become steeper. The change in gradient has to be greater and greater. That means we want this part right here. So you exclude this one and the graph looks like this, okay? You can apply this every time. You don't have to memorize what the curve is. as long as you know these, what dy dx is and d squared dy dx squared, you should be able to sketch any curve on this table right here. So let's look into another one. Dy dx bigger than 0, so two possibilities only, okay? Either that curve or that curve. Positive gradients, and then on your column side, d squared y dx squared is now smaller than 0, so the rate of change is negative. So that means the gradient is decreasing. It doesn't mean gradient is negative or positive, it just means the gradient is decreasing. And in that case, this part, the one on the left, is decreasing. See, very steep over here, and then less steep over here. So the gradient is decreasing. You take out this curve, okay? Right. Now, let's move on to the bottom two cells. Dy dx is now smaller than 0. So smaller than 0, you can get this curve right here. That's a negative curve. And then you can get this other curve, which is also negative. Now, which curve is it? We can only pick one, right? You go look at your second derivative. D squared y dx squared is bigger than 0. That means the gradient is increasing. Now, which one is increasing? Okay, this is a big positive, okay? Very steep, big positive. But then on the right hand, on the rightmost point of the curve, the gradient is now small negative. But because you have a big negative, let's say negative 100, and it's changing to negative 10, for example, the gradient is actually increasing because negative 100 is a very small number, right? And then negative 10 is bigger than negative 100. So the gradient is increasing. So in that case, right here, it's becoming less steep. And for this side on the right curve, the gradient is negative, but not that steep. And then it becomes very steep, okay? Very, very steep. But then it becomes very steep negative, then your gradient, your rate of change of the gradient is actually decreasing. So we want to pick the one that's increasing, so less negative over time. And in that case, you pick the first one, the one on the left, and you don't pick the second one, okay? Same thing applies over here. You have two possibilities, either that curve or you get that curve, okay? So this is very steep negative over here, very steep negative, and then less steep. Well, we know that one was d squared y dx squared bigger than 0, so the only other possibility is we take the one on the right. And it makes sense, right? Look at this. The point is not that steep. It's negative, but not that steep. But over time, as it moves along the curve, it becomes very steep, so very negative. And the more negative you get, then of course the gradient is actually decreasing, okay? Right, so that's the four cells that's really important for understanding concave up and concave down. Right, okay, let's look into the other cells. Now, for this cell, bottom cell right here, dy dx equals 0. So that means we have a gradient of 0 or a flat curve, okay? So you get only two possibilities, either this one right here or this one. So you either have a min or a max. Now let's look at d squared y dx squared bigger than 0. If d squared y dx squared, the second derivative, is bigger than 0, that means we have a concave up, right? So from our example right here, we have a concave up, and concave up means your gradient is increasing over time. Let's look at which one has a gradient that is increasing. So this is a very negative gradient, very steep, but then over time it becomes 0, but then afterwards it becomes very positive. And in that case, gradient is actually increasing. So this is the right one. We have a minimum. When the first derivative is equal to 0 and the second derivative is bigger than 0, we have a minimum. And when the second derivative is smaller than 0, then of course we pick the other one, which is your maximum. And it makes sense, guys, so do not pick this one right here. And it makes sense for this part because the gradient is very positive at the left, it becomes 0, and then eventually it becomes very negative. So the gradient is decreasing over time, just like this, concave down, right? So you get a maximum, okay? And let's move on to the last column. So that is when d squared y dx squared equal to 0. So the second derivative is equal to 0. What that means, guys, is you get something called a point of inflection. Right, let me take a minute to explain to you guys what a point of inflection is. So a point of inflection is when the concavity of a curve changes its nature. So if, for example, it started being concave up, in this case, this curve right here, this is concave up, and then at that point, it shifts over to concave down. So we know this is concave up and that is concave down. Then this point right here is what we call the point of inflection. So it's when the concavity changes sign, okay? There's four possibilities. You either get this, you can also get this one right here, concave down, and then goes to concave up. That is your point of inflection. You also have this one right here, this part, so on the left part until the point, that would be concave down because the gradient is decreasing, it's getting steeper negative, and then it changes to concave up because now the gradient is getting less steeper, but then it's becoming less negative, okay? Right, so that point is the point of inflection, and of course you have the other side as well, it's reflection. This is concave, so concave down, concave up, I'll just label that. This is concave up, but then now it's concave down. This would be concave up, and then concave down, and concave up. Okay, now we have to put all of these into our columns. Let's have a look at what they can be. So when dy dx is bigger than 0 and d square y dx squared is equal to 0, which one of these do we take? So let's have a look at the point of inflection. So we're only looking at the point of inflection here, okay? Now, which gradient is positive at the point of inflection? Right, so the possibilities, of course, is when the gradient looks something like this, right? Something like that. So at that point, this point of inflection, your gradient is positive, but your d squared y dx squared equal to 0 because at that point is the change, okay? The change in concavity. So the rate of change of the gradient at that point is 0. Right, and then on the second part, right here, dy dx is smaller than 0, so gradient is negative. So essentially, you know, these two curves, and what it looks like is this. Right there, it's just the reflection, okay? So gradient is negative, but at that point, the concavity changes, just like we discovered here. Now let's look at the last cell. Dy dx equals 0, so we have actually a flat point. It can't be any of these because the gradient is positive here, the gradient is negative, it's not 0. So what does that leave us? Well, if the gradient is flat, that means it's either min or max, right? But remember, there's another stationary point, another type of stationary point, and it is your stationary point of inflection, okay? The ones that look like this, right? And it makes sense, guys. Have a look. At this point, the gradient is flat, and let's look at the second derivative. So the second derivative is equal to 0, so either side of the point is when the concavity changes. So on the left part of this curve, the gradient is decreasing, so that's concave down. It starts off with concave down, but then after the point of inflection, the gradient starts to increase again. It gets steeper, right? So that's concave up. So it went from concave down to concave up. So therefore, that is a point of inflection. Now, let's look on the second part. This is a very steep gradient, negative though. So it is changing, it's becoming less steep. That means concave up because your gradient is then increasing. And then after the point of inflection, it becomes really steep. So it went from not as steep to very steep, negative. So the gradient is actually decreasing because it's a negative gradient. So it went from concave up to concave down. So that means there is a point of inflection in the middle. And of course, that is your stationary point of inflection shown in this graph, okay? So guys, this is pretty much the table. I hope you understand this. Point of inflections are becoming more and more important throughout the year. So expect it to be in the exam as well. You know, study up for it, revise a little bit, and I'm pretty sure you'll be fine, okay? But aside from that, guys, I hope you found this video useful, and I'll see you in the next video.